Let's talk about the proof of Squeeze theorem. What is the proof of Squeeze theorem? We're going to discuss graphically and mathematically that how we can prove Squeeze theorem. Let me take XY plane here. This is my circle. Let me make a triangle here. So this is my radius R. Here is my theta. This is my A. This is my O. Here is my B. This is my C. I have a circle. I want to prove the Squeeze theorem graphically and mathematically. For that reason, I took XY plane. I have a circle, and then I made a triangle here. From here, from the origin up to this border, it is R, which is the radius of the circle. So at this point is my A. Here is my O. This is my B here, and this is my C, and this is my theta. Now we know that AC over OA equals to tangent theta, because look, OA is cos theta along the x-axis and AC is sin theta along the y-axis. What is tangent theta? Tangent theta is sin theta or cos theta. AC, from here up to here, AC, this AC is my sin theta. OA, this OA, from here, OA, from here up to here, it is my cos theta. Look in the polar coordinate, the x-axis is cos theta, the y-axis is sin theta. It is a simple algebra. Perpendicular of the triangle is a sin theta, and base of the triangle is a cos theta. It is perpendicular and this is base. So tangent theta is sin theta or cos theta. What is sin theta? Sin theta is AC. AC is my sin theta. What is OA? OA is my cos theta. So sin theta or cos theta equals to tangent theta. But now, at the same time, when you look to the cos theta, from here up to here, which is OA, it is R, it is a radius. This yellow line is a radius, which is cos theta, but at the same time, it is a radius R, R of the circle. So can I put OA equals to R? Yes, just put OA equals to R. Replace OA by R equals to tangent theta, and then multiply both sides by R, so I will have AC equals to R times tangent theta. So my AC equals to R times tangent theta because I plugged OA equals to R. From here up to here, this is the radius of the circle, which is R. So I just replace OA, which is cos theta, by R, and then I multiplied both sides by R, so I will have AC equals to R into tangent theta. This is the value for the AC. But the area for triangle AOC equals to 1/2 into R times tangent theta. It is the formula for the area of a triangle. The formula of any triangle is 1/2 times base times perpendicular. Look, I want to find the area of a triangle AOC. AOC. From here, AOC. C. I want to find the area of this triangle. Now, the formula for any triangle is 1/2 into base into perpendicular. What about base? Base is cos theta, which is this yellow line. But what is this yellow line? The yellow line is the radius R. It is R. OA equals to R. OA is R. So just plug R for the OA and then times perpendicular, which is AC. AC is sin theta. But what is the value of AC? AC is R times tangent theta. Just plugged R times tangent theta for the AC here. So I will have 1/2 into R times R into tangent theta. For the base, I plugged R, which is the radius of the circle. For the perpendicular, I plugged AC. Now R times R will be R square, so I will have 1/2 into R square into tangent theta. This is going to be the area of a triangle AOC. Now to find the area of the sector AOB, it equals to 1/2 into R square into theta. What is my sector? Look, I have done with the triangle AOC. Now I'm going to find the sector area. This round area, this round part from here up to here. AOB. What is AOB? We're going to include this sector, this curve part, This curved part is the sector. It is a sector AOB. We want to find the area of sector AOB. What will be the area of that sector? The formula of the sector AOB will be 1/2 into r square into theta. This is the formula for the sector. It is the formula 1/2 into r square into theta. R square is this. You're going to take the square of the radius and then times theta. 1/2 into square of radius times theta will be the area of the sector when it comes to find the area of the sectors. This curved part from here up to here, including this curved part, this whole region is 1/2 into r square into theta. This will be the area of sector AOB. But what about the area for triangle AOB? It equals to 1/2 into r sine theta, which equals to 1/2 into r square into sine theta. Look, we have done with the triangle AOC, which is AOC. I have done with the sector AOB, because I'm including this curved part from here, including this curved part. All this region, the formula for all this region is 1/2 into r square into theta. But I haven't done for the triangle of AOB. There is another triangle AOB. What about the area of the triangle AOB? The area of the triangle is the same, 1/2 into base into perpendicular, which is 1/2 into r sine theta. It equals to 1/2 into r square sine theta. But how I got r sine theta? Let me explain you. We know that AB or OA equals to sine theta. Perpendicular from here up to here, AOB or AO is called sine theta. It is sine theta. Sine theta equals to AB or OA. Look, I'm not talking about AOC. I'm talking about AOB, triangle AOB. So AB perpendicular or OA base equals to sine theta. This is my sine theta. What about OA? OA is my radius. From here up to here, this yellow line is my radius of the circle. So just plug R for OA. It equals to AB or R equals to sine theta. Multiply both sides by R, so we'll have AB equals to R sine theta. There I got the value of AB, which is R into sine theta. We know that the area of the triangle is 1/2 into base times perpendicular. What is my base? Base was R, which is the radius. It is cos theta. But what is perpendicular? Perpendicular was AB from here up to here. Because I'm talking about triangle AOB, not triangle AOC. I have done with this. And also I have done with the sector AOB. Now I'm talking about triangle AOB. So it will be 1/2 into base, which is R, times perpendicular, which is AB. But the value of AB we just derived is r sine theta. So I directly plugged r sine theta for AB. I just directly plugged AB equals to r sine theta. We got it from here that AB or OA equals to sine theta. OA is R, so plugged R for the OA and then multiply both sides by R, so you will have AB equals to r sine theta. Just plug r sine theta for the AB here. R times R will be R square. So this is gonna be the area of the triangle AOB. Triangle AOB. So we got all the three values. Area of the triangle AOC, area of the triangle AOC, which is 1/2 into r square times tangent theta. And also area of sector AOB, area of sector AOB. This curved part, including this curved part, its typical formula is 1/2 into r square times theta. Square of the radius and then times theta. And also the triangle AOB, which equals to 1/2 into r square sine theta. Now I'm going to present all these three equations in the Squeeze theorem statement. According to the Squeeze theorem statement, sector AOB equals to and greater than triangle AOB, equal to and less than triangle AOC. It's like this is my one function, this is my another function, this middle, This is my third function which has been sandwiched or squeezed in between them. Sector is less than AOB but greater than AOC. Again I repeat it. Sector AOB equals to and greater than AOB but less than or equals to AOC. How? Let me go back to the graph. This is my sector from here. From here, this is going to be my sector from here. Now, the statement says that this sector is greater than triangle AOB. Because look, my triangle starts from here up to here. This is my triangle AOB. When you look to the sector is a curve part. It is a curve. So this region is extra. This region is extra. So I say that sector AOB is greater than triangle AOB. Because it is pretty clear from the graph that I have a curve part. This region is a bit extra. So the sector is greater than triangle AOB. It may be equal to triangle AOB. But at the same time, it is less than triangle AOC. Less than triangle AOC. Because my triangle AOC is bigger than sector AOB and also triangle AOB. According to the Squeeze Theorem statement, sector AOB equals to or greater than triangle AOB but equals to and less than triangle AOC. Why sector AOB is greater than triangle AOB? Because sector is this curve part, this gray curve part. This is the extra region which is greater than triangle AOB but less than triangle AOC. So I hope you got it now. Now to plug in the area of triangle AOB, which is here, and area of sector AOB, which is this, and area of triangle AOC, which is here. Just plug that values. The area of triangle AOB is 1/2 into r square into sine theta. Area of sector AOB is 1/2 into r square into theta. Area of triangle AOC is 1/2 into r square into tangent theta. Now to divide this whole expression by 1/2 into r square, just divide this complete expression by 1/2 into r square. So you will get this new statement. Look, when you divide this complete expression by 1/2 into r squared, this 1/2 into r squared cancel. Also this 1/2 into r squared cancel and 1/2 into r squared cancel. Because I divide this complete statement, which means that I divide all the three terms by 1/2 into r squared. So I will left only with sine theta here and theta here and then tangent theta here. But what is tangent theta? Tangent theta is sine theta or cos theta. Now to divide this complete statement by sine theta, so I will have again this new expression. Just divide this complete statement by sine theta. So sine theta divided by sine theta will be 1 because sine theta goes with the sine theta. So I will have 1 on the left side. For the middle I will have theta or sine theta. Here I will have 1 over cos theta because when I divide sine theta or cos theta by sine theta, the sine theta will cancel and I will left only with 1 over cos theta. Just divide this complete statement by sine theta. If you turn around this statement, you will get it in this way. Just give a turn to this statement. Theta or sine theta will become sine theta or theta, and 1 over cos theta will become cos theta. Your inequality bar will be changed. If it is greater, it will become lesser. If it is lesser, it will become greater. If you give a turn to the statement, your denominator will be numerator and your numerator will be denominator. Similarly, denominator becomes numerator and numerator becomes denominator. It will be cos over 1. So cos over 1 is cos. But then don't forget this equality bar. If it is greater, it will be lesser. If it is lesser, it will be greater. They will be the other way around. Just give a turn. So this is going to be my new statement. Now to apply the Squeeze Theorem statement, which is limit of sine theta or theta where theta approaches 0 equals to and less than limit of 1 where theta approaches 0 equals to but greater than limit of cos theta where theta approaches 0. Just plugged in this statement in Squeeze Theorem statement. It is according to the Squeeze Theorem statement. Look, limit of a constant where theta approaches 0 will be the same one. So limit of 1 where theta approaches 0 will be the 1. And limit of cos of theta where theta approaches 0 will be 1, because when I plugged theta equals to 0, cos of 0 will be 1. So I will have limit of sin theta or theta where theta approaches 0 equals to and less than 1 equals to and greater than 1. Just put the limit for the left side and for the right side. Don't disturb the middle part. We know that it is a constant. There is no theta variable to plug theta equals to 0. Therefore, the limit of 1 where theta approaches 0 will be the same 1. But the limit of cos of 0 where theta approaches 0 will be 1, because when I plugged theta equals to 0, cos of 0 is 1. Now look to this final expression. Limit of sine of theta or theta where theta approaches 0 equals to and less than 1. But at the same times, it equals to and greater than 1. So less than 1 and greater than 1. What do you mean? Just think about it. If a function equals to and less than something, but at the same time it equals to and greater than the same something. The situation like we have it here. This middle function equals to and less than 1, but equals to and greater than 1. So at one end it is less than 1, but at the other end it is greater than 1. So I can say that there is no way for this middle function other than to say that this middle number is also equals to 1, because it equals to and less than 1 and equals to and greater than 1. It has been sandwiched. It has been squeezed within this one and this one. This middle function cannot run away from this limit. It must be also equal to 1. If your mind is still not very clear, just look to the statement. Look to this expression and think of it, that if this middle function limit of sine of theta or theta where theta approaches 0 equals to and less than 1, but on the other end it equals to and greater than 1, there is equality as well. So it equals to and less than 1 equals to and greater than 1. In other words, in other simple words, we can say that this middle function has been trapped. It cannot run away. It has been trapped. So whatever value the other function has, it must has the same value. Suppose this one is for the g function and this one is for the h function. So h is 1 and g is 1. So this middle function, which can be f, must have the same 1 value. Because remember, according to the Squeeze theorem, all the three functions, function g, function h and function f, meet at the same point. They approach to a same exact value. So when it comes to approaching the same exact value, they must have the same value, which we just proved it here. So at the end I can write that the limit of sine of theta or theta where theta approaches 0 equals to 1. So there it has been proved that the limit of sine of theta or theta where theta approaches 0 equals to 1. I repeat it. If this middle function equals to and less than 1, but on the other hand it equals to and greater than 1, so it means that this middle number is also 1. If g is 1, h is 1, this middle function, which is f, is also 1. So limit of sine of theta or theta where theta approaches 0 equals to 1, because g equals to 1 and h equals to 1. So this also equals to 1. That's how we have proved that the limit of sine of theta or theta where theta approaches 0 equals to 1. There I got the mathematical and graphical proof for the Squeeze theorem formula, but also for the Squeeze theorem mathematical expression. Well, this expression also has been proved. Just think for a while that the area of triangle of AOB is my limit of g of theta where theta approaches 0. And this area of sector of AOB is my limit of f of theta of where theta approaches 0. And this area of triangle of AOC is my limit of h of theta where theta approaches 0. So by applying that Squeeze theorem mathematical expression here, at the end I got limit of sine of theta where theta approaches 0 equals to 1. So here is the proof for the basic squeeze or sandwich theorem, and also for the mathematical expression of the Squeeze theorem. We have proved this mathematical expression here, from here, and also we have proved this formula at the end by using this mathematical expression.